Hello everyone, welcome to my YouTube channel. This is Anu here. Today we are going to discuss about the capacity planning of a WhatsApp-like messaging system. Today we are going to discuss about WhatsApp-like platform. We are going to see the capacity planning of such kind of platform for around 100 million users. Um, as discussed earlier, in my previous video, I have shown the template. I am going to use similar template to do the calculations and all. As usual, I am going to the glossary first. There we can see what are the terminologies which used for doing the capacity planning. And then I will go to the README. There I can show you what are the parameters I am using for doing the calculations. Then we'll do the capacity planning. And finally, I will go ahead and do the architecture explanation for this kind of use case. Let's go ahead and see the glossary. In glossary, if you see, there are around 29 terms are there, 29 to 31, that depend upon the platform to platform. Let's go one by one. The first one is daily average user, that is DAU. Okay, that is usually around 30 to 70% of the monthly average users will be the daily average users. Next, come to the request user per day, that is average action per user per day. It is an input observed from the analytics. Chat is around 30 to 60. If you consider as a WhatsApp, usually in an average, a person will do 30 to 60 chat per day. Total requests per day, that is all requests handled by the system in 24 hours. That is daily average users into the previous count. Previous count is a request user per day. That will give the total requests per day. As of now, WhatsApp is handling around 80 billion requests per day. Let's come to the read-write ratio. This is the how many reads happen per single write. Suppose if I'm sending one message, the how many users are going to read this. Suppose if it is a broadcasting, it is a one to many. One to one and one to many is there. If I'm sending only to one person, it is one to one. If I'm sending to a group, that will be a one to many. This kind of thing. Next, come to the total RPS, requests per second. That is load measure used in the size server, used to size the servers. Okay. Requests per day divided by number of seconds in a day, that is 86,400. Peak requests per day, that will be usually around 3 to 4 times the request. Peak request is calculated on the basis of 3 to 4 times the previous calculation. Peak RPS, the highest RPS during the traffic spike. We used to take around 3 to 4 times. That average RPS into peak factor. Peak factor should be either 3x or 4x we used to consider. Record size, average bytes stored per write. That is a record size. Usually it will be 2 to 5 for the most applications. Sorry, record size. That will be a test message around 100 to 300 bytes. If it is a tweets kind of thing, then it will be 500 bytes. It will be 500 bytes. Okay. Daily storage growth, how much storage we require to handle this kind of data per day. That is new bytes added to persistent storage per day. That is writes per day into record size plus media. That is the daily storage, because we are not going to write only the messages. We need to send images or videos and all. So that's also added into the total storage usage. That will comes around to 69 terabytes a day in actual calculation as of now with the WhatsApp. Next, come to the bandwidth. That is the data mode over the network per second. That is request per second into payload size. It is considered into converted to GB per second. That is we will be getting the value in MB. That has to be multiplied into 8 to convert into bits, from bytes to bits, then divided by 1000, it will give the GBPS. And for WhatsApp, it is around 150 GBPS is the average bandwidth. This is a cache level. How much data we need to keep it in the RAM, for fast access. That is a hot fraction into daily storage. Hot fraction means it will be around, that depend upon company to company. It will be around 60 to 80% in case of WhatsApp kind of thing. Around if it is YouTube kind of thing, then it's around almost same 60 to 80% or 50 to 70% like that. We can use Redis caching or memcache. That is as of now here it is calculated on 10 to 20% hot data. That depends upon company to company. Here we are calculating around 10 to 20% of the hot data in the cache. If it is a streaming kind of thing, then we need to consider the caching little bit higher level. Database size, that is persistent storage size, including index, overhead, and all. That will be raw data means if you're considering the database, whatever the data we are sending, it is going to be saved in the database. In that case, if suppose 100 MB is the data I'm sending, then we need to consider around 40% of the overhead because there will be metadata and other factors is coming into the system for saying the a database. So around overhead percent 20 to 30%, 40% is typical for overhead. Replication factor usually will take around 3 replicate to give the redundancy and fault tolerance for the data. DB size into factor usually it will be 3. A CDN content delivery network, it is going to cache the metadata at edge location, that is media bandwidth into peak factor. Size per region traffic split. And backup, that we need to consider about the backup for disaster recovery. If something goes wrong to the primary location, we need to switch back immediately to the backup location. That is daily, weekly, or monthly, how we are going to do the backup and all. That depend upon the importance of the data. Replicated DB into retention multiplier, that is 1.5 to 3 times is the of the primary. That is the backup is. The retention period, how long the records are going to kept in the server. Usually for WhatsApp kind of application, 1 to 7 years is the typical. After that, that data and metadata will be removed. Next, come to the GBPS, that is gigabits per second. When we calculating the bandwidth, it will be calculated on bits, not on bytes. So what are the bandwidth we are getting? If it is in Mbps, we need to multiply with 8 to convert into bits, then divided by 1000, it will give the Mbps. If it is in GBps, if it is Mbps, this is how we will be calculating the bandwidth in GBps. Next, come to the 80-20 rule. What does it mean? 20% of the data serve the 80% of the request or traffic. That is how the 80-20 rule means. That we use most of the time. That will be our cache calculation comes into picture. Cache will be 20% of the daily storage used for the size of Redis server. This is backup envelope. That is quick estimation. It can be plus or minus 50%. That's quick calculation, not the actual one. A WebSocket, that's a persistent TCP connection for real-time messaging. We are using WebSocket. Then far node, that is delivering one message to and receiving that to one-to-end mapping for the messaging delivery. And shading, we use the shading for database replication for fast access because the database size will be very huge. One single server cannot handle. What we can do is we can do shading, indexing, and kind of things. Those kind of principle we can apply on top of database to expand the database first only. That shade is equal to total storage divided by shade capacity. Typically, 1 to 10 terabytes will be the shade capacity. Shade size. Write-ahead log, we are using the write-ahead log to recover from the crash. The hot standby is the replica that can instantly take or primary files. That is backup and disaster recovery concept. Let's go ahead and see the README. What are the parameters we are considering to do the capacity planning for this kind of application. Here we are using daily average user request per day per user. That is, we have seen around 40 as a request per day per user. Then we are using total request per day, that is daily average user into, that is DAU into request per day per user. And then read rate ratio, that is then read RPS, write RPS, speak RPS, and these are comes under the request per second. We need to convert the read request here divided by number of seconds per day. We will get all these calculations. Data size per record, average bytes stored in the system per write event. Daily storage growth is new bytes added to the persistent storage per day. Then daily storage growth, that is a daily growth into 365, that will give the yearly storage growth. Next, come to the bandwidth, that is read plus write throughput in Mbps or GBps, that will give the read throughput. Then cache requirement, that is for database, usually it will be around 20 to 30% of the total data. Database requirement, that is primary, plus we need to consider the backup databases for redundancy. Replication factor, how many copies we need to save in order to keep the system alive in case of any fault tolerance of any redundancy issues. So that comes under the replication factor. CDN requirement, that is for content delivery network from this is to avoid the latency, high latency. Backup requirement to avoid unplanned downtime. If there is some issue happening, we need to switch back to the DR system or backup system immediately. And future growth, we can consider for 2, 3, or 10 years. We are going to calculate for all those three parameters. That is, we are going to see for 3x, 5x, and 10x how the data growth and estimation goes. Units for reference, 1 KB, you can say it as 1000 byte. 1 MB, it's 10 raised to 6 bytes. 1 GB, 10 raised to 9. 1 TB, 10 raised to 12. 1 PB, 10 raised to 15 bytes. Okay, to convert them into bits, we need to multiply into 8. 1 day, it's going to say 86,400 seconds. Yes, see the calculation from GBPS, that is gigabytes per second to gigabits per second, that is MB per second into 8 divided by 1000. Let's see the capacity planning, how we are going to do. This is for 100 million daily average user scenario. These parameters we can change, that is given in yellow. If you want to change the parameters, we can change it here. Daily average users, we are 100 million users. Daily average user, request per day per user is 40, that is average request, read or write request coming from one single user. Read rate ratio is 5. Each message written by one user will be read by at least five recipients. And peak average traffic, we are considering as 3 times the normal traffic. And average size per record, that is 200 bytes. Media attachment size, that is 10 percentage. Attachment rate, 10% of the people are attaching media. Okay, average media file size, it will be around 200,000 bytes. Then cache hit is 20%. Cache hit and cache miss, then that comes under the CDN. Cache hit means, suppose if I am requesting some data, if it is available in the CDN, that is called the cache hit. If that's not available in the CDN, then it has to go to the origin server and pull the data and send it back to the user. That's called cache miss. And if there is a cache miss, what the system will do is it will go and pick up the data from the origin server. From there, it will serve the user, and from there onwards, the data will be served in the CDN system. So the next time onwards, it will pick up the data from the cache server. And DB overhead, that is index plus metadata, that we are expecting around 30% of the total storage. That means if 100 MB of the data I have to save, I have to consider around 130 MB in size. A replication factor, I'm considering it for 3, and backup retention multiplier is 1.5 times. That is daily, weekly, monthly retention versus primary size. Data retention period is 5 years. After that, it will be removed. And seconds in a day, that is 86,400. Based on these assumptions, we are going to do the calculations. Okay. Daily average usage, that is, we already seen, that is 100 million per request per user per day, 40. So total requests per day will be around 80 billion. This is the daily average user into request per user. That is, this is the actual value. We are not considering this one. This is the calculated value. Okay, that is around 4 billion. It's calculated around 4 billion requests per day. Write share total, that is 16.7%. That is read share total, that is 83.7. That is, if one person is writing one message, it is expected to read by at least minimum of 5%. That is a 1:5 ratio. Total writes per day, that is around 600 million or 666 million. Next, come to the total reads per day, that will be around 3 billion or 3.3 billion, we can roughly say. And average reads per second, average read RPS, that is around 38,580 requests per second, and average write per second, that is around 7,716 requests per second. These are per second read request and write request. Average total RPS, it is addition of these two parameters, we will get around 46K. So that peak Total RPS is peak means maybe 3 times or 4 times this calculated by as of now we have calculated around 3 times of this average total RPS. We are getting around 138K. Average data size per record we have considered as 200 bytes. So daily storage measurement it will be this many bytes. That is 133 billion bytes per day. Raw data storage required is going beyond a trillion like that. And data growth will be this much trillion bytes per day. We need to convert them back to the GB, TB, and petabytes. Total data storage in growth, it's considered into GB. It was initially it was bytes, that is converted into GB. It's around 1300K, we can say GB per day. And daily storage growth will be around 13.47 terabyte a day. Okay, this is in GB. Now we have converted back to the terabyte. Divided by 1000, we will get the terabyte. Next, come to the yearly storage growth. We had to multiply this value into 365. We will get this many terabytes. That is 4,915 terabytes a year. That is when it converted into petabytes. That will be 4.92 petabytes a year. Next, come to the write bandwidth. That is around 155.8 is how we are calculating. That is write RPS in average payload divided by 10 raised to 6. Read bandwidth, that is 779. That is a 5 times the write bandwidth, because we are considering as at least 5 people are reading the data what we are setting. So that will be around 5 times. We are getting around 779 Mbps. That is read RPS in the average payload divided by 10 raised to 6. Total bandwidth required, this is the sum of read bandwidth plus write bandwidth, that is around 935. We are considering around 1 Gbps, we can say. Total bandwidth required is 7.48 Gbps. That is Bps into 8 divided by 1000. Peak bandwidth will be the 3 times of the total bandwidth. That will be around 22.4 for Gbps. That we are calculating average Gbps into peak factor. Okay, next come to the total cache requirement. Cache, that is a hot data, that will be around 2693 Gbps. How we are calculating this? We are taking the daily storage into cache, that is 20%. Daily storage we have already calculated on top. Daily storage growth will be around this much, 13.47 terabyte. This is the value. If we take the 20% of this value, we will get 2693. 0.67 terabyte. Sorry, gigabyte. Next, come to the raw database size. This is the raw database size over retention, 24,576.67 terabyte. That yearly terabyte into retention year. Retention year, we are calculating around 5 times, so 5 years. Next, come to the DB size with overhead. It's around, we need to consider with the plus 30% of the overhead. That plus 30% of this value, we will get around 31,949.67 terabyte. Total DB size with replication, that will be, we are considering 3 times the replication. So this value into 3 times, we'll get around 95,849 terabyte as a DB size with replication. This is how we are calculating this data set, because each layer, if we go down the line, the complexity of the data storage is increasing, and the amount of storage we need to consider, that volume is also increasing. And media bandwidth is 771.60 Mbps, that we are calculating the read RPS into media rate into media size divided by 10 raised to 6. We will get it in the Mbps size. Content delivery network peak bandwidth is around 18.52 Gbps. How we are calculating? We have the media in MB per second. We have to convert that into GB per second. Backup storage requirement is 143K terabytes. That is a replicated database into a backup multiplier. This is how we are calculating the backup storage requirement. These are the capacity planning. It includes the daily average user planning and total requests per day. Next, we have calculated how much daily storage we need. Then we have calculated how much bandwidth we need. Then from there we have calculated how much cache requirement and backup and disaster, how much backup we need, and what are the database storage size. These are the parameters we have calculated based on our assumptions. Next, come to the future growth. Here we are going to see This is the calculation we made. If we are considering this as the value, this already we have calculated here. Okay. If you're considering this value, how much is the storage and other parameters required, or other 3-year, 5-year, and 10-year values. So if you see daily average user, that will be 1 million. In 3 year, we are expecting around, 100 million. 3 year, we are expecting around 300 million. This is just a multiplier. Just we multiply with the 1 year value, you'll get the 3-year, 5-year, or 10-year values. It's not beyond that. This is the yearly growth. Yearly growth projection. It's around percent annual growth we are expecting. And from year 2, 3, and 4, there also we are expecting around, if we are considering around 15% growth per year, this will be the expected value in 5 years. Let's come to the database and infrastructure design decisions. We need to consider the messages that the recommended storage is Apache Cassandra. And user profile, we can use the PostgreSQL, and contact and group, that also we can store in PostgreSQL. And media and metadata, we can consider as a MongoDB. Then sessions and persistence, we can use a Redis cluster. And search index, we can use Elasticsearch. And for media storage, that we can use S3 or GCS, that depend upon the cloud provider. These are the estimated size for each one of them. Next, come to the AI model evaluation. I have evaluated this model. This is our base model. I have used the calculation what we have calculated from the base assumptions. From that, I have used those values to estimate the compare with the existing throughput of the WhatsApp. This A model validation, I have used these many GPT models to calculate the exact output based on the current value, current WhatsApp user count, 2 billion daily average user for WhatsApp. Okay, we have considered only 100 million, but the actual value is around 2 billion daily average users. And based on that, it has populated these values. These are the values calculated by GPT-4o. This is by Claude 3.5 Sonnet, and this is by Gemini 1.5 Pro. And Llama is calculated around this one. It's around variance is around 8 to 10% of the variance in every model. And comparison with the existing ecosystem, this is our current value we have estimated, and with the actual value, it's around this. This is the actual value. It's around almost around 20x ratio we are getting. That's all about the capacity planning. Let's go ahead and see the architecture. In architecture, we have this is around 7-layer architecture. One is client layer, edge and content delivery network, API gateway, microservices, message queues, and data layer, observability, and inference ops. Let's go ahead and see what are they. If you see this client layer, we have this client layer at OS, Android app, or web app, or React, or iOS app. From there, the request is coming to the edge content delivery network, where we have DDoS attack or web application firewall, media content delivery network, or global load balancer. Then those requests will go to the API gateway, that is a WebSocket server, REST, or gRPC API server, Kong, or Nginx. Then or service. These are used for reverse proxy to isolate the existing system with the entire outside world to avoid unwanted attacks. And or service in JWT, OTP, and OTP, and rate limiter for we can use for Redis as the rate limiter. And for the next, come to the services. So all services are using microservice architecture, so that the downtime of one application will not affect the other services, and we can do horizontal scaling depending upon the load for each services. For message service, you can use Erlang or Go. And presence, we can use Redis or Redis PubSub. And media service, we can use Python or Go. And notification, we can APNs and FCMs. And group, we can Go and PG. And message queue system, we can use Kafka cluster for fan out for message queuing system, that is one to n mapping for that, and Redis PubSub for real time. Data layer, we have for the messages, we can use Cassandra. For saying the user details and all, we can use a Postgres. For caching, we can use Redis. And media storage, S3 bucket or GCS or Azure blob storage we can use. And for the message shares, we can use Elasticsearch. And finally, the observability and infra ops, we can use Prometheus, ELK Stack, Jagger or Zeppelin, or Kubernetes or Terraform. Infra asset as a code we can use. Okay, these are the 7 layers in this architecture. Hope you understand what are the things we have covered here as a part of capacity planning and the architecture discussion. Hope you enjoy this video. Thank you. Have a good day. Bye.